Hi, hello, hello. Today we shall be developing VECM model, right, or vector error correction model. And three here are three steps involved in developing VECM model. So step number one, lag selection, right? That is step number one. And step number two, Johansen test of cointegration. And the final step is the vector error correction model. Okay. So the first step is the lag selection that we do first, right? Lag selection. How many lags we should select to run our model. Okay, and here you can see we have three variables, cons, ex, and gdp. Three variables, cons, ex, and gdp. I open all variable as a group that you can see from here, right? What is cons? Cons means consumption, ex means export, and GDP means gross domestic product. And we have the data from 1960 until 1995. Okay, so the first step is the lag selection. Okay, I go to quick, then I go to estimate var, right? Then here I put my three variables, cons, ex, and gdp, and here I take lag 2 for the time being. I take lag 2, then I press OK. So actually this is the vector error correction model, and here you can see cons, ex, and gdp. These are the dependent variable, and from this model we can select the lag, right? Okay, I go to view, then I go to lag structure, then I go to lag length criteria, that I go. Okay, here the lags to include, better I take 4 lags to include, right? 4 lags to include, then I press OK. So here you can see the outcomes, right? So here are few criteria are here, you can see. So here the criteria is LR, FPE, AIC, SC, and HQ. And here is given LR means this one, sequential modified LR test, FPE, final prediction error, AIC, SC, HQ, and these are the lags, right? These are the lags. Okay, so here the first one is LR, and here one thing, you can see a star here, right? Star indicates lag order selected by the criteria. So here suppose in case of LR, so the star is here, that means 27.47, meaning that 3 lag should be chosen. Okay, and here we have the second criteria, FPE, star is here, meaning that 3 lag should be chosen. And here the AIC, so here what is happening, lower the value, better the model all the time. and here you can see 17.32 is the highest and 2.189 is the lowest. Lower the value, better the model. So this value is the lowest, and that is why there is a star, right? So meaning that 3 lakh should be chosen. And also here also the same guideline, the lower the value, better the model, and here 3.44, this value is the lowest, and that is why the star is there. And here HQ, also the same criteria, lower the value, better the model, and here 2.64 is the lowest, and that is why there is a star. Okay, now actually all criteria are good. Now it is up to you to decide which criteria you will choose. That is up to you. All are good. Okay. But here what is happening, if I take LR, so 3 lakh is asking for, and FP also 3 lakh has been recommended, and also AIC 3 lakhs have been recommended, and also HQ 3 lakhs have been recommended. So that means here 1, 2, 3, 4 criteria are asking to take 3 lakh. So better we take 3 lakh in our model, meaning that optimum lakh would be 3, and we shall use this 3 lakh in Johansen test and also in the vector error correction model, right? Okay, so the lakh selection is done. Okay, now the second step is the Johansen test of cointegration. Okay, we proceed with the Johansen test of cointegration. That is number 2 step. But the precondition of Johansen test is what? There is a precondition: variables must be non-stationary at level, but when we convert all the variables into first difference, right, then they will become stationary, meaning that all the variables should be integrated of same order. Only then we can run the Johansen test of cointegration. So variables must be non-stationary at level, but when we convert the variables into first difference, then they will become stationary. And if it is happens, then only we can run the Johansen test of cointegration. Okay, we check actually what happens about our 3 variables, right? they will become. I put it become, right? Okay. Okay, now we check our three variables. Okay, so we check one by one. First I go to quick series statistics, then I go to parallelogram. So the first variable is cons, right? That I select first. Then I press OK. Okay, first I check at level. That means the variable is at the raw data, the initial data. That I select label, then press OK. And here you can see the parallelogram of cons at level, and you can see the Q statistics and corresponding probability value, right? And here, what is our null hypothesis? Null hypothesis that variable is stationary, right? And alternative hypothesis, variable is not stationary, right? That is alternative hypothesis. And here the p-value is very small, less than 5%. So we can reject the null hypothesis and can accept the alternative hypothesis, meaning that variable is not stationary at level, right? So that means variable is not stationary at level. Okay, now I check what happens after the first difference of the cons variable. So I go to view, I go to parallelogram. So this time I select first difference, this one, right? Then I press OK. Okay, here you can see the Q statistics and corresponding probability. Suppose this one, probability is 6.6%, this one 18.3%, and this one 30%. All are more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that variable is stationary after first difference. That means d cons, you can see d cons, this is stationary after first difference, right? Okay, so that is done. Now we check our second variable. So I go to as before, series statistics, parallelogram. I take the EX, our second variable, right? I check this one, export. Okay, so I take at level. So this is the outcome. You see from here, right? This is the outcome. And parallelogram, EX, as before, Q statistics and corresponding probability. Here the p-value is less than 5%. We can reject the null hypothesis and can accept the alternative hypothesis, meaning that this EX variable is not stationary at level. Okay, now I go to view and I do the parallelogram as before, and I take the first difference of EX variable, right? I press OK as before. You can see this is the first difference of EX, and Q statistics is here, and the p value, you can see all are more than 5%. That means we cannot reject null hypothesis, meaning that our first difference of EX is stationary. Okay, then we check our third variable. that is GDP. I think the GDP is the last term. I put it GDP, right? I do it. Then I press OK as before. So I choose that level, right? So this is the outcome of GDP. You can see. So it is the probability value. You can see we can reject the null hypothesis and can accept the alternative hypothesis, meaning that GDP, this variable, is non-stationary at level, but I go to view correlogram, but when I choose first difference, right, then what happens? So I press OK. So we call it correlogram of DGDP, first difference of GDP. What happens here? You see Q statistics and corresponding probability value. So probability value all are more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that the first difference of GDP is stationary. So what is our summary? Summary is our three variables are non-stationary at level, but when we convert all the variables into first difference, then they become stationary. That means all our three variables are integrated of same order. So now we can easily run Johansen test of cointegration because precondition has been met. Okay. So we run the Johansen test of cointegration. I go to quick, then I go to group statistics, then I go to Johansen test of cointegration. Okay, so here I put our three variables, cons, EX and GDP, and here these three variables are non-stationary. Make sure here we must put non-stationary variable, right? And we know that after first difference they will become stationary, that we have just seen. Okay, I press OK, and here lag selection, here I take lag 3 because lag 3 has been said by the lag selection criteria, and here I select 3, right? Then I press OK to run the Johansen test of cointegration, and it is here, right? I run it. Yes, the result is coming up. You can see the result from here. This is the Johansen test of cointegration that you can see from here, right? Just going down. Okay, going up. Okay, Johansen, and we have three variables. Okay, and Johansen test of cointegration, right? It is here. Okay. Okay, first we check trace statistics. Okay, so and we have three variables. Okay, and it is the null hypothesis, number of cointegrating equation or number of cointegrating model. So the first null hypothesis is none, meaning that there is no cointegration, there is no co-integration among the three variables such as cons, EX and GDP. that is the null hypothesis. That means none. Okay, here the trace statistics how much? 35.66, and critical value at 5% is 29.79. So what is the guideline? The guideline is that if the trace statistics is more than critical value, we can reject null hypothesis. And here 35.66 is more than 29.79, meaning that we can reject this none. And also we can check it from the probability value. Here probability value is very small, 0.94%, which is less than 5%, which is less than 5%, meaning that we can reject this null hypothesis, which is none. Okay, now our second null hypothesis is at most one, meaning that there is one cointegration model, right? At most one. Okay, here is this the statistics is how much? 8.51. Critical value is 15.49. So here statistics is less than critical value. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is at most one cointegration model. And also from the probability value, the p-value is 41.25%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is at most one cointegration model. And the result is also given here. Trace test indicates one cointegration model at 5% level, because here is 5%, right? So meaning that our three variables are cointegrated. That means cons, EX and GDP are cointegrated, or in other words, our three variables cons, EX and GDP have long run associationship, or in the long run they move together. Okay, then our second test is maximum eigenvalue test, and the thing is same, almost same. Number of cointegrating equation or model, the null hypothesis is none. All right, there is no cointegration among the three variables. And here is the statistics. 27.15 is more than critical value 21.13, meaning that we can reject this none hypothesis. And also probability is very small, 0.63%. We can also reject null hypothesis, meaning that this one, which is none. Okay, then we come here at most one. Here 7.84 is less than 14.26. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is at least one cointegration model. And also the probability value is telling the same thing, and the probability value is 39.51%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is one cointegration, at least one cointegration model. And the decision also given here, max eigenvalue test indicates one cointegration model at 5% level, meaning that our three variables such as cons EX and GDP are co-integrated, or they have long run associationship, or in the long run they move together. Okay, now what we have seen, trace statistics and maximum eigenvalue test, they are telling the same thing, and that is our three variables cons EX and GDP are co-integrated, or they have long run associationship. Okay, so and now now what is the guideline if the variables are co-integrated or have long run associationship, then we can run restricted var, and that is VECM model, that means vector error correction model. But if the variables are not co-integrated, we cannot run VECM model. Rather, we shall run unrestricted var. But here our three variables are co-integrated, so we can easily run vector error correction model. And in the next video, we shall run it. We shall run the VECM model, okay, in the next video. Thank you very much for being with me.